Let's talk about mirroring and how we might do that in code. The idea of mirroring is that we take an image and draw a line and take the pixels or the image from one side of that line and invert it onto the other side. Most typically this is done in the middle of an image, such as this line I've drawn here. We could also have a horizontal line where we mirror the top to the bottom or the bottom to the top. And if we're mirroring vertically like this, we could mirror the left side to the right or the right to the left. The example we're going to take a look at today is this vertical mirroring, where we take the pixels on the left side and move them to the right. And so let's make a copy of this before we do anything, and then we'll actually see how the pixels end up moving. I'm just going to put that over there so we've got that as a reference when we're done. So from a mirroring standpoint, this yellow pixel in the top left corner, we're going to kind of like fold it over on this middle line, and so this yellow pixel we want to go here. So let me copy that and we'll paste it back over here. And the same thing would be true for all of these in this column. I'm going to grab those all at once and paste them in. So this whole first column is moved over to the far side column. And then similarly, all of the pixels in this next column are going to go into the next to last column. And lastly, in this example, all of these are going to go here. So in my example, I just have an imaginary 6x6 pixel picture, and so the pixels in the first column go into the last column, in the next column go into the next to last, and in the third go into the third from the last. And so we end up with this sort of appearance as opposed to the original that we had. So how do we do that in code? Well, I just happen to have some. So here we go. We've defined a function called mirrorVertical, given a picture. We're going to get the width of that picture because we then are going to calculate the mirroring point, or that middle line, by dividing the width by 2. And notice we're doing integer division, so we make sure we end up with an integer rather than a real number. And then we've got nested for loops like we've seen before. For x in range, for y in range. The x is going to go from 0 to the mirror point, because remember, if we come back and look at our image, we only want to go from here to halfway. We don't want to go all the way across. So we only go to the mirror point that we calculated as half the distance. However, in the case of the y-axis, we want to go the full distance. So we're going to go from 0 to the height of the picture. And once we've got our x and y ranges working, it's going to give us all possible combinations of coordinates that we need to move from the left side to the right. So let's get the first pixel. We want to get the pixel from the left side that we're going to copy over by doing a get pixel of picture at x and y, just simply using the coordinates that are generated by the for statements. And then we need to get the right pixel, the place we're going to copy the pixel into. So we do a get pixel of picture, and the y is simply going to be y, because we're not moving it vertically, but we are moving it horizontally. And so we have to do a little math to calculate that. We're going to take the width of the picture minus the current x value, which is where it's coming from, and then minus 1. And we need that minus 1 so we don't go off the edge of the picture. Because remember that the width is what we normally would think of as width, but the indexing starts at 0. And so we need that difference of 1. When we think about moving it from the very left edge, x is 0, and so we have width minus 0 is width minus 1, gives us that 1 less, which is the last x value in the picture. When x is 1, the second time through the outside loop, it's going to be width -1, -1, which gives us the next to last column. So after we've got the 2 pixels, we get the color of the left pixel, the one we're copying from, and then we do a set color into the right pixel of that color. And so that's effectively transferring the color from the left pixel to the right pixel. We go through the loop, if all possible combinations, and when it ends, we've copied all of the pixels from the left to the right in a mirroring fashion. So let's run it and confirm that this actually works. Let's get a picture. I'm going to choose the shops picture. And let's run our mirror function using pick variable I just created. It's completed. And let's show our pick. And here's what we've ended up with. And in case you aren't familiar with the picture, let's reselect it and show the original. So here's the original, and here is our mirrored version. So notice, imagine drawing a line here in the middle. Everything on the left side has been mirrored onto the right side. Again, the very left edge going to the very right, the middle going to the middle. And that is what it takes to mirror a picture. Again, we can think about mirroring horizontally instead of vertically. I'm going to leave that as an exercise to the reader to think about how you would change your logic here to mirror vertically instead of horizontally, or horizontally versus vertically. I'm also going to leave it as an exercise to the reader to think about how we would move the right side pixel to the left instead of, in this case, we moved left to right. So there's a basis for mirroring here, but we have lots of other variations we can do with it. We'll see you in class.